So let me know if you can see my screen.
Okay, yes.
Okay, good. So Prince, we're good, right? Prince, can you hear us?
I can see it.
Okay, good. All right, so we just today we're going to um, talk about databases generally, and we're going to talk a little bit about the internals, and then we'll do some practicals, some scripts, and talk deeply into the internals. Okay, so overview, concepts, definitions, and preliminary information. So this definition, I'm sure we're already familiar with it, that a database is an organized, structured collection of data designed for ease of access, manipulation, and management. And most relational management database management systems, they create what can call an abstraction layer between what you call physical structures and logical structures. Let me try to explain the difference between that in simple terms. Now, when you log into your database and you query a table, you see a structure that looks like a two-dimensional structure with rows and columns. And you query it and you are able to retrieve your data. It presents the results set to you in that two-dimensional structure. But if you go to your operating system, you're not going to see any entity that looks like that. You're not going to see any two-dimensional structure on your operating system. What has happened is that your database system has extracted that data from however it is stored on the operating system as in quote flat files, and is presenting it to you as a logical structure, which is called the table. The same thing with your indexes and so on and so forth. Now, when the data is stored on your operating system, in essence, when you look at it, when you go to see where your data is stored on the operating system, what you're seeing is a physical structure. You see a data file. And inside that data file, there's a breakdown to other physical structures. Now, logical versus physical. On the database system, you will see file groups in SQL Server. In Oracle, they are called table spaces. You see tables, you see indexes, and so on and so forth. On the physical side, on the operating system, when you go to where your data is actually stored on the operating system, first of all, the first thing visible to you is your database files. You can use queries to begin to dig deeper into the structure of that database file to see other physical structures such as extents and pages and so on and so forth. The smallest unit of abstraction that is available in SQL Server is called the page, and it's 8 KB in size. I think we'll get to that as well. Now, database files are typically structured in three ways, or named in three ways. One is MDF. Some people try to allude the meaning on MDF and NDF and LDF, but typically you can think of MDF as a main data file. I don't think it's the official definition, but the first time you create a database and you don't specify any file options, the first file that comes is labeled or named an MDF file. I'll show you this practically. And you can all your data is stored within that MDF. The other file that you see is the LDF, logical, or not logical, a log data file, if you wish to call it that way, log data file, where your transaction log, basically the transaction log file for that database. If you create another file to store actual data on your database, every other file you store will be named as a .ndf. Nobody knows what N means. Maybe somebody can tell me. I have not come across. So basically, these are how your data files are, or your data files are named in SQL. I'll show you this practically, and you will see the details as well. Now, we talked about pages being the smallest unit of storage in SQL Server, and they are 8 KB in size. In Oracle, you will see what you call blocks. A block is also the smallest unit in is the same thing actually, but it is called pages in SQL. It is called the block in Oracle. And you notice if you have any exposure to storage terms, they also use the term block, and it's 8 KB in size, 8 kilobytes in size. That's the smallest unit. So when you write a row will typically sit, a row of a table will typically sit inside one page of storage in SQL Server. When that row is so big or so long that it exceeds 8 KB, it will now roll over and fit in another page. It will have to split itself and sit on another page in SQL and go on. So that's when you have what you call row overflow data, where your data is too big to sit inside 8 KB. It had to split itself along the line of several pages. It has its own performance issues that it comes with, because then SQL Server has to now navigate several pages to retrieve your data. An extent is another logical expression which refers to a group of 8 contiguous pages. So when you line up 8 SQL Server pages side by side, you form what you call an extent. There are two kinds of extents: uniform extents, which store pages for just one object. That is, if I create a table inside SQL and all the rows, all the data in that table is piled up along a series of pages, we call and that number of pages amounts up to 8 pages, we call that a uniform extent. All the data in those pages are from one single table. It's a uniform extent. If they are from different tables, if different tables have put some of their data in that extent, what is happening is that you have what you call a mixed extent. All right, we'll try to see some of these things pictorially later. Then other concepts that you want to think about or know about are allocation maps. In SQL Server, for each block of storage, so to speak, for each page, for each page within a certain number of pages, you need certain, you can think about them as metadata. Certain pages that are reserved. They are reserved to show you information about a larger set of pages. For example, the first one is called the global allocation map. And what it does, it's a page on its own. It's an 8 KB page. So it has information about the next 4 GB of data. It has information on that page. So it will write, if it writes 0 on and says, okay, this 0 refers to page so and so and so on the next 8 KB, is saying that that page has not yet been used, right? If he says this 1 belongs to this so and so page of in this at this location, it means it's telling itself that that page has been used. So when you write data in SQL Server, now SQL Server uses that information in the global allocation map to determine where to put your next set of data. So you do have there is some work to be done in determining where to write your data in the physical structures based on the information in these global allocation map pages. Each GAM page, like they normally call it, tracks 4 GB of data. So for every 4 GB of data in your data file, there's a new GAM page. For every 4 GB, there's a new GAM page. And it makes sense to have not too many GAM pages because of contentions are associated with determining where to put your data. You get? So that's why when you are dealing with data files in SQL Server, it's good to have a certain size of your data file to make sure that you are not having too much contention related to GAM. Typically, I'll just keep my data files to like 100 gigs. Some even want to keep it smaller. Instead of extending the data file, simply create a new one. All right, there is the second type of allocation map called the shared allocation map. Shared allocation map pages. These pages are used to track mixed extents. So for every, if you have basically a bitmap on that, in that page that says, okay, 1 means that the extent, that extent that bitmap is associated with is a mixed extent. If it's a 0, it is not a mixed extent. Again, the SGAM pages track up to 4 GB of data. Then you have the IAMs, the index allocation map pages. They track pages and extents used by different objects. So each table or index, each structure of such has its own set of IAM pages. So these are like metadata kind of these pages. They are all pages, but they are reserved in SQL Server to store metadata about the way that data is allocated, that pages are allocated within your data files. That's basically what they are used for. There's much more information on them when you start going to the internals of SQL Server. All right. So I hope I'm capturing the screen. All right. So basically, there are also two extra types of allocation maps: the differential change allocation maps and then bulk change maps. The differential change, basically, that is what SQL Server uses to know where the last differential backup stopped. That way, it's able to, when you do a differential backup, it's able to know where to start from, because what a backup is doing is basically keeping a copy of the extents that have changed since the last full backup or since the last differential backup. So it needs to know where that change stopped, what is the last page, where is the last extent that was touched in that last backup. Bulk change map, the same thing with when you're doing bulk log recovery model. In the bulk log recovery model, SQL needs to know where you stopped, where the logging stopped. You get, to be able to know, okay, I've backed up this extent and I need to continue from here. All right. Okay, 1 minute, please.